Today's problem, minimum operations to connect hospitals, difficulty medium. You are given an undirected network of V hospitals numbered from 0 to V minus 1, represented as a 2D array. Edges, where element edges at I equals UV, denoting a direct connection between hospital U and hospital V. In one operation, you are allowed to remove any existing link and reconnect it between two hospitals that are currently not directly or indirectly connected. Okay. Your task is to determine the minimum number of operations required to make sure that all hospitals become connected. If that is impossible, connected either directly or using a given link. If that is impossible, return -1. Okay, let's look at an example. We have 0, 1, 2, 3, 4 hospitals here. Now, 3 of them are connected in a cycle. Now, there's an extra link here. And so we can disconnect that link between 1 and 2 and reconnect it between 1 and 3. Now everything is connected. So the output there is 1. On this one, all the hospitals are connected already. Output is 0. We don't have to rearrange anything. All right. Constraints. V, number of vertices is between 1 and 10 to the third, 1,000. Number of edges is between V times V minus 1 over 2. And the edges. Edges. Okay, so they're just saying that the edges array will consist of valid vertices between 0 and V. Expected complexities. V plus E, auxiliary space, V plus E, topic tags, graph, disjoint set. All right. When you see disjoint set, that suggests that you're going to use a union find algorithm. There are some elements of the union find algorithm, and we're not going to discuss it in detail. We're going to just use this as a little bit of a black box, although I'd encourage you to familiarize yourself with a union find algorithm in your programming language of choice. It may be possible in an interview that you could just say, I'm going to use a union find class here. I mean, the basics of union find is union find operates on disjoint sets. It has 2 operations. One, union, meaning that you can give it 2 sets and it'll union those into a single set. Find, you can give it a vertex and it will tell you what set that vertex is in. Okay? We're going to use a property of union find that we usually don't use, but in this case it's going to come in handy. So okay, let's take a look at this. Union find. So we create a new union find. We pass in the number of vertices. Now a union find will initially just create however many vertices we tell it to create and count each one as its own disjoint set until we start unioning things. Okay, so now if we go down here and start looking at our edges. Okay, so we have 0, 1 as an edge. P and Q, and let's see, are they already connected? Now, connected includes indirectly connected. So what is that called? What is that called? Transitive is what I'm trying to think of. So like if P is connected to Q and Q is connected to R, then P is connected to are. So, all right, first edge comes in, 0, 1. Are they connected? No. So we'll skip the if, and then we'll do a union of P and Q. Okay, so now those are connected, and we only have three disjoint sets. Next edge, 0 and 2. Are those connected? No. You will union those, and now we have only 2 disjoint sets. Let's see. Next edge is 1, 2. Are 1 and 2? Well, so yeah, okay. I keep saying connected, but what it does is it finds what set is P in and what set is Q in. That's 1 and 2. Well, as it turns out, they're in the same set. So when we say, are those equal? Yes, they are equal. They're already connected. So we don't need an edge from 1 to 2. So we are going to count that as an extra edge and just continue. Now, at that point, we're done adding the edges. Now, another thing that union find will do, in addition to doing unions and finds, it is after you run it, it'll give you a count of how many disjoint sets are left. Now, whatever the count is of disjoint sets, we're going to need count minus 1 extra edges to be able to connect the disjoint sets into one set. So that's what the final test is here. If a number of extra edges is greater than or equal to count minus 1, then we do have enough extra edges and we can just return count minus 1. If that is not the case, then we have to return -1, meaning we can't, how do they put it here? Yeah, we can't connect all the hospitals into a single network. All right. What else? No, I think that's it. It's just it's a disjoint set union find problem. So let's try running it. Okay, so you can like the video, subscribe to the channel, and notifications, and we'll see you next time.